In this video, we're going to prove the identity for the hyperbolic sine function and hyperbolic cosine function that 1 plus sinh squared is equal to cosh squared. Now, if you aren't familiar with the hyperbolic trig functions, their definitions are given in the problem here. And cosh x is defined in terms of exponential functions as 1/2 times the quantity e to the x plus e to the negative x. Sinh x is the same, except there's a minus sign between the exponential terms. So ideally in our proof, we want to start with the left-hand side and manipulate it until we can turn it into the right-hand side. And it really helps here to just do a little bit of prep work and figure out what cosh squared is going to look like so we can recognize it on that right-hand side. So just as a little side note, I want to look at what cosh squared x looks like. And so we're going to take this exponential thing and square it. And the two factors of 1/2 give us a 1/4. And then we have e to the x plus e to the negative x multiplied by itself. So when we start distributing with this product of two binomials, it starts with e to the x times e to the x, and that's e to the 2x. And then we get a repeated cross term. I have e to the x times e to the negative x, which is just e to the 0 or 1. And the other cross term is going to be the same thing. So I end up with 2. And then my final term is going to be e to the negative x times itself, which is e to the negative 2x. All right, so this is basically what we're going to be looking for in our proof. So now I can go ahead and start the proof, and I want to start with 1 plus sinh squared. And then we'll go ahead and plug in the definition of sinh and square it while we're working. So I end up with a 1/4, and then e to the x minus e to the negative x multiplied by itself. And we end up with a similar set of terms here. My first one's going to be e to the 2x. And again, I get a repeated cross term, but this time it's negative. So I have e to the x times negative e to the negative x. That's -1. And it happens again with the other cross term. So I end up with a -2. And finally, plus e to the negative 2x. So the key to transforming this into the thing that we're expecting here, the square of the cosh function, is that we're going to factor a 1/4 out of both terms. And when I pull a 1/4 out of the 1 out in front, that becomes a 4. Now, if that seemed like a strange trick to you, just redistribute that 1/4 over these two terms and you get what you started with. So we can tell that it works. So I end up with a 1/4. And now I have a 4 and a -2, so I end up with a 2 from that, and I'm going to go ahead and write it in this order, e to the 2x plus 2 plus e to the negative 2x. And we've already shown that that's equal to the square of the cosh function. But we're going to pretend for a moment that we actually see the factorization from scratch. And this factors into e to the x plus e to the negative x, multiplied by the same thing again. And then we realized we could split the 1/4 into a 1/2 that applies to each of those factors, giving us the square of the cosh function, and we're done. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.